Please hit subscribe.
This problem appears at the qualifying examinations for applicants for Japanese government or MEXT scholarships 2020. This problem is from the 2020 mathematics questionnaire for the Specialized Training Scholarships. The answer key and the original questions are linked in the description. In this video, we will attempt to solve questions 6 to 10 of problem 1. For problem 6, we are given a regular octagon. From 8 vertices, how many diagonal lines can be drawn? So we will just count the number of diagonals. We start with a regular octagon. So this is how I draw it. And then we can start anywhere, but here we will start at this vertex here. And we will just draw the diagonals from this vertex. And of course, we cannot draw a diagonal to the sides directly beside, or to the points, the vertices directly beside this vertex. And so our diagonals would look like this. From this to this, here, 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 here. And again, no diagonal to this side. And for this first drawing, we have 1, 2, 3, 4, 5. And for the second diagonal, we just move counter, or rather clockwise. So for the second vertex, we start here. And again, we draw the diagonals and we get 1, 2, 3, 4, 5. So for these first two vertices, we get 5 plus 5 equals 10 diagonals. Now we just move to this vertex and we notice that we do not have to draw diagonals to the points that we've already considered. So we will always end at this vertex here for when we consider the diagonals. So for example, if we start here, we only need to consider this, 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 and this. So again, we don't go back to the start. And now we only have 4. And then we do that for this bit. And we notice that we will just have to reduce by 1 every single time. And that accounts for a reduction in a vertex that we need to consider. So for example, if we start here, we get these 3 green diagonals. And again, we end here because we've already considered this, this, and this. So if we don't have to draw this to here again. And so we have 3 there. And so we can guess that from here, there will only be 2. From here to here. And the last one from here would be just 1 here. And now here, when we're back here, we don't have any diagonals left anymore because the only remaining vertices would be this vertex and this vertex. And we already said that the vertex beside the other vertex will not have a diagonal. So the last diagonal is just 1. That is from this to this. Now we just add them all together. 10 plus 4 plus 3 plus 2 plus 1. And we get 20. For problem 7, we are given the geometric progression a8b and the arithmetic progression ab minus 8. And we are asked to look for a and b such that a is greater than b. Now, to solve this problem, we need 2 equations because we have 2 unknowns, a and b. And the 2 equations must be independent. And the way we get those equations from this problem is to use the 2 independent conditions. The first independent condition is the geometric progression, and the other, the arithmetic progression here. So let's do that. First, let's just write down this condition here to remind ourselves. Then we start with the geometric progression. For the geometric progression, we know that the common ratio must not be 0, because if it were 0, it would be 0, a 0, 0. So that's not really helpful. So we can rule out 0 as a possibility. And if it's not 0, then we can have the following relationship. The geometric progression that is given, a8b, is the same as a and the second term a times r. So 8 must be a times r. And the third must be, we just multiply it again with r. So a times r is ar squared. And therefore b is equal to ar squared. And we just write that down again. 8 equals AR, B equals AR squared. And now we have to remove R because we're only interested in B and A. So the way we do that is we notice that here we can have R equals 8 over A. And so we replace the R here with that 8 over A. And so 8 over A squared, because that's R squared. And if we do that, we get 64 in the numerator. We get A squared in the denominator times A. We are left with A in the denominator. And let's just make this a little bit more beautiful, and we see AB equals 64. We do that by multiplying A to both sides. Now for the arithmetic progression, let's assume that the common difference is B. And now for this common difference, we can have the given arithmetic progression to be equal to A, which is the first term, and then we add a D, which is the second term. So A plus D is B. And we add another D. So A plus D is A plus 2D, and this must be -8. And we just write that down. B equals A plus D, and -8 equals A plus 2D. And again, we just want to remove D because we're only interested in A and B. So D equals B minus A, and that's just from this bit here. We just subtract A from both sides. We get this. Now we replace the D here with a D here. And so we get -8 equals A plus 2, and the D is replaced with this one. And if we just simplify that a bit, we get -8, 2B, and here we have -2A, plus A is -A, or rather, we can write it A, we move A to the other side, and we move A to the other side, A equals 2B plus 8. From the previous slide, we obtained the two equations that we need. So AB equals 64 and A equals 8 plus 2B. This first equation can also be written as A equals 64 over B. Now, we have to solve these for A and B. And the first equation is used here. So 64 equals A times B. And A is replaced with this one. So 8 plus 2B. And B is retained. Now, let's continue by dividing both sides by 2. So this bit here becomes 32, and this bit becomes B times 2B divided by 2 is B, 4 divided by 2 is 4, and that becomes 32 equals B squared plus 4B. Now we notice that we can actually complete the square here very easily by adding 4. So let's do that. If we add 4 to both sides, we get this expression on this side and this expression on this side. And what we're trying to find is B. So if we continue, we get 36 on this side. We get B plus 2 on this side. Again, this is a perfect square. That's why we get this B plus 2. And now we can just get the square root of both sides. So we get B plus 2, which is the square root of this side here, equals plus minus the square root of this is 6. Now we can just move 2 to the other side. So we get -2 plus or minus 6. If we use -2 plus 6, we get 4. If we do -2 minus 6, we get -8. So that means we can have two possibilities, B equals 4 or B equals -8. So let's start with B equals 4. If B equals 4, then A, we use this, A equals 64 over 4, which is 16. The other possibility is if B equals -8, then A equals 64 divided by -8. And so A is equal to -8. However, we are told that A must be greater than B. But in this case, the second case is such that B is -8, A is -8, so B equals A. Therefore, we don't want this. We only want this because here we have 16, which is A, and B is 4, so 16 is greater than 4, so it satisfies this. And therefore, A equals 16 and B equals 4. Problem 8 asks the radius of the inscribed circle of an equilateral triangle where the side length of 6 is blank. So let's consider an equilateral triangle. In an equilateral triangle, all three sides are equal, and also all three angles are equal. And because the sum of the sides of a triangle, or rather the sum of the angles in a triangle is 180 degrees, and if each angle is equal to the others, then we just divide 180 by 3 and we get 100, or rather just 60. So 60 here, 60 here, and 60 here. Also, in an equilateral triangle, we know that the median is the same as the altitude, which is also the same as the angle bisector. So here we drew a median. So a median is the line segment drawn from a vertex to the other side, such that the point on the other side is the midpoint of this side. So that's what a median means. And for an equilateral triangle, this median is the same as the altitude and the angle bisector. So a median, as we mentioned, would bisect this side. So because this is 6, then we have 3, 3. This is the median. Also, this median is the same as the altitude. The altitude is that line segment such that it is perpendicular to the opposite side. So this bit here is 90 degrees. This is also the angle bisector. So the angle bisector is that line segment that bisects this angle here. And if this is 60, because it's an equilateral triangle, then each of these would be 30. And also, if we draw the other medians, so this is one of the medians, the other medians could be drawn here and here. They all intersect at one point if it's an equilateral triangle. And that intersection is actually the center of the inscribed circle. So the inscribed circle is the circle that is tangent to all three sides of your triangle. And so this is the center. This is where the medians, the altitudes, the angle bisectors intersect, and this is also the center of your inscribed circle. Therefore, this length from here to here is your radius. And this angle here, because this is also an angle bisector, this will be 30 here. And now we have a special triangle, 30, 60, 90. And we know that if you have a 30, 60, 90 degree triangle, then the side beside the 30 degree triangle, 30 degree angle rather, this side is actually square root of 3 times the side opposite it. And so to get the side opposite it, we just divide this by square root of 3. And so we obtain r equals square root of 3. For the 9th question, we are asked to find n, such that if we sum this expression from k equals 1 to k equals n, the sum is 7 over 8. Now, for these kinds of problems, I noticed that when you have something like this, we can actually decompose this into two terms, such that we will get a telescoping sum. So this is what I mean. First, let's decompose this into two terms. Let's use partial fractions. And so 1 over this is equal to a over the first factor plus b over the second factor. Again, if we recall for partial fractions, if the exponent here is 1, here is 1, then the numerator would have to be constants. So a and b here are constants. Now, if we multiply both sides by this denominator, then we obtain this. 1 equals a times k plus 1 plus b times k. And we have to obtain b and a. So if we substitute k equals -1 and k equals 0, we will get the values of a and b. So here we do k equals 0 first. So k equals 0, this will be 0 here, and here will be 0, and so we have a equals 1. Now we do k equals -1. If we do that, then this expression here goes to 0, and there, and here it's -1. So negative b equals 1, therefore b equals -1. And now we can express this sum as follows. This bit here is actually 1 over k minus 1 over k plus 1. And this is a very good form for a sum. And that's because this is what we call a telescoping sum. If we write that down, so 7/8, it's just 7/8 here. This is just a given. And now we can write the given like this. So now we have this. And if you actually start to write down the terms in this sum, we see the following. So let's start with k equals 1. So 1 over 1 minus 1 over 1 plus 1, which is 2. Now if k equals 2, we have 1 over 2. 1 over 2 plus 1 equals 3. So 1/3. Now let's do 3. So 1 over 3 minus 1 over 3 plus 1, which is 1/4. So 1/3 minus 1/4. And if we do k equals n minus 1, then we have k, 1 over n minus 1 minus 1 over n. That's this. And k equals n would be 1 over n minus 1 over n plus 1. And notice that this is a very good form because now these terms, this term cancels with this one. This one also cancels with this one. 1/4 also cancels with the next, and so on. And in fact, this one also cancels with the term previous to it, and until this one also cancels with this one. Therefore, we are left with 1 minus, so just this term here, and this term, 1 minus 1 over n plus 1. And again, this is equal to 7 over 8 in the very beginning. Now, we just move this around. So we get 1 over n plus 1. We move 1 over n plus 1 to the other side, and 7/8 to this side. So that becomes 1 minus 7/8, which is just 1/8. Therefore, n plus 1 is just 8. And so n equals 7. Question 10 reads, when a differentiable function f of x satisfies the equation, this equation here, then f of x equals blank and a, which is the lower limit of integration here, is blank. So we need to find the function f of x and the constant here, a. The first thing we notice is that f of t here is inside an integration symbol, and we're looking for that f of t. So the inverse process of integration is differentiation, and this is given by the fundamental theorem of calculus. So let's recall the fundamental theorem of calculus. It says that if you have an integral like this, you have an integral, so this is the integral here. If you differentiate this integral with respect to the limit here, x, so d dx of the limit of the variable here, x, then you obtain the inner function here, which is f, and now the variable will be x, so f of x. So this is the fundamental theorem of calculus. That means to obtain f of x, we just differentiate this side and differentiate this side. And let's do that. So f of x now, from the fundamental theorem of calculus, we differentiate this, and this expression is equal to this, so we differentiate this. This is just 2x minus 2. So f of x is 2x minus 2. Now we will look for a. We start by integrating f of t, because now we know what is f of t. So here we just write the given. So this is the given from here, and here from here. But now we know what is f of t. It's just 2t minus 2. So because we found f of x, we can just replace x with t to get f of t. And now we have this, so let's do the integration here. The integral of 2t is just t squared, and the integral of 2 is 2t. And the limits from a to x is written this way. And now we just replace t with x, so x squared minus 2x for this bit, minus, we replace it with a, so a squared minus 2a. And now we see that this is equal to this. Write that down. So this came from the given, and this came from our integration. Now we can see that this first term here actually cancels with this, and the second term cancels with this, and we're left with the third term, 1 equals the negative of a squared minus 2a. Now if we multiply both sides by -1, then we get a -1 here, then we add -1 to both sides, we get 0 on this side, and on this side we get a squared minus 2a plus 1. Now that's a perfect square, so there's only one solution. And if we do it this way, we get a equals 1. If you learned something new today, please help my channel by clicking the subscribe button and the bell for the notifications. See ya!